So let's define the language accepted by a DFA, let's call it M, is the set, well, it's the set W in sigma star, so all strings such that M has an accepting computation on W. And we usually denote this by L. So L is the language. That's actually not right notation. I'm going to move this over. And it's really L parentheses M. So whenever we are going to say L parentheses the machine, that's the language of that machine. So informally, this set is just the set of all strings that it accepts. So like the first example where we had all strings of odd length, the language of that machine would be all strings of odd length. Okay, so that would be an example. Yeah. So this is the language accepted by a DFA M, and we say that a language L is regular if it is accepted by some DFA. Okay, so if I assert to you that a certain language is regular, that means some DFA has that language. So let's look at some examples. What about the set of all strings? So is sigma star the set of all strings regular? In other words, is there some DFA that has that language? So basically the DFA that accepts everything, never goes to a non-final state. Yeah, how would I make it? Yeah, simply. Yeah, so just a single state like this, and it loops on everything. Everything in sigma, I guess.
Can you just write it like that?
Yeah, but we'll be talking about a particular sigma in pretty much every other place. This is just an arbitrary example. So like for instance, we'll talk about sigma is equal to 0, 1 as the characters, and then you would write 0, 1 on the transition. This is just to handle all possible cases. What about the empty set? So basically the language that has nothing in it at all. So it's completely empty. So the DFA here should accept nothing. What's the language of that? What's the DFA for that? Yeah, same idea. But instead of making the one state final, it's non-final. So here's the same thing. Let's see. Let's address a question that you might have. What about this language? So this language, is the third one here equal to the second one? No, why not? What's a simple proof of that? Yeah, there's one element in the third one. How many elements are in the second one? 0, the empty set. So there are clearly different languages. Okay, so how would I actually do this? This one's a little more complicated. So if the string has any characters at all, I don't want to accept it. So what do we do there? Can I get away with one state? No, I don't think so. So let's see. What about the start state? Does it have to be accepting? Yeah. How would I get the empty string if the start state is not final? So the start state has to be final. So remember, we're only accepting the empty string and not accepting all of the other strings. Well, what if I have any character in the input? Should I stay in this state?
Just exit out.
Yeah, exit out of it on anything. And so I'm going to do a shorthand here by saying anything in sigma goes on this transition. And what about the state that it goes to? Should it be final? No. And what about transitions on this second state?
Just stay there.
Just stay there. So, so here are some examples of regular languages. How do you know that they're regular? Because I can make a DFA for them. What's another example of a regular language we saw last time? The very first example we did. Yeah, the strings of odd length when they're completely composed of zeros. So another example that we saw last time was, so all strings that are entirely zeros, such that the length of W is odd. What about the same language except I interchange even for odd? So even length instead of odd length. Is that one also regular? Yeah, and what's the simple proof of that? What do I do to the odd DFA to make it into the even one? Switch the final states. Huh. So let's think about that for a second. If I have a DFA and I just switch the final and non-final states, that gives me obviously another DFA. But how is the second guy's language related to the first one? It's the exact opposite. It's the complement of that language. But we're going to get to that soon. So all of these are regular because there's a DFA for them.